All right, I'll give you till 10:37, and then we'll go over the warm-up. Oh, excuse me.
You want me to say
All
my
right, does anybody want to? What's up?
Oh, no, I was just saying that if you want me to say my answer.
Yeah, go ahead if you want to share.
So I got 28.
28. Anybody get anything different, or do we agree? All right, let's check it out. So plugging everything that we have.
If you're sharing your screen,
Right, we
you're
get.
not.
I'm not sharing my screen.
No, you're not showing the where you write. You're showing our class. Now we can see
Is
it.
that better? Okay, my apologies. I must have clicked the wrong button when I clicked shared screen. All right, so yeah, okay, so we said 28. That was one of our answers, so let's double check. So we have 8 factorial over 8 minus 2 factorial times 2 factorial. All right, so there is our equation. And my apologies, I didn't realize I wasn't sharing the screen, so you didn't have this in blue. So this would become 6 factorial. So I'm going to write it out. But remember, we can simplify and hopefully make it a little easier for us. Right, so the 8 factorial we have up there, and then 6 and 2. So we can cancel out almost everything in the numerator with the 6 factorial. So we're left with 7 times 8 over 2. And 7 times 8 is 56. 56 over 2 does get us 20. Good job. Okay, so we're going to go through a couple different things today, and we'll see where it gets us. Maybe we'll be done with this part, the binomial theorem. We'll see. So one of the things that you may be asked to find is to find a specific term in a binomial expansion. Right, so we're going to learn how to do it to find the whole thing. But if I'm just looking for one specific term, I don't want to, especially with something like this, x plus y to the 10th, I don't want to expand that, right? It's going to have 11 terms, x to the 10th, and then something x 9th, y to the 1st, and then, it would go on for a while. That's a lot of calculations. So yesterday, we saw part of the equation. I'm going to put it over here. To find, now it's going to be a little different, and this doesn't really make sense, but find the rth term. I guess that's what you would say. Rth. Yeah, I don't know. That's strange, but I don't know what else you would call it. So we're not finding the nth term anymore because now we're using n as whatever power we have here, right? Actually, we'll say nth. Okay, so we want to find the rth power of an nth power. Find the rth. Oh man, I'm off today. My apologies. Term of an nth power binomial expansion. So yesterday when I was starting to write it out, came up with this for our Earth term. I feel weird saying that, but I guess I don't have anything else. So the way it kind of works is we do the combination. Okay, that's what this is called, the combination. I don't know if I mentioned that yesterday. We do the combination with the power combined with the whatever term we're looking for. And then our first variable, or our first term, is going to be n minus r. And then our second term, the second part, is just going to be to the r power. All right, so I want to find the third term to this. So I have my n is 10. That's the power that they give us. And I have my r is 3. And really, that's all you got to do. And then you can just plug what we need to in. So the third term of this expanded all the way is going to be 10c3 times x to the 10 minus 3 times y to the third. We can simplify the variables before we do anything, so I'm going to leave this as 10c3 right now. And that's going to be x to the 7th, y to the third. Now, a general hint, your exponents should always add up to whatever power your expansion is. All right. So because we have to the 10th power, 7 plus 3 is going to give us 10. All right. They should always add up that way if you're dealing with variables. Okay, I'm going to show you if we don't have variables in a second. So now the only thing we have left to do is calculate 10 combo 3. So I'll do that over here. That's going to be 10 factorial, and I'm just going to skip a step and do 7 factorial over 3 factorial. So a little different than we saw before. 5, 6, 7, 8, 9, 10. And you don't have to do this every time. I'm just doing it because I don't feel like grabbing the calculator. All right. Just if you're plugging this into the calculator, make sure you put the denominator in parentheses. Don't accidentally multiply by √3. So here, we're going to cancel out all the way up to 7. And then we can actually even do further simplification here. I can get rid of this 2, divide it into the 8. That's going to leave me with a 4. I can get rid of this 3, divide it into the 9, and that's going to get me 3. So 4 times 3 is 12. 12 times 10 is 120. So the final answer is going to be 120 x to the 7th, y to the 3rd. All right, and I'll show you how we can double check that in a moment. So let's talk about it when we don't have a variable. Okay, when we have something like x minus 2. So like a normal binomial, you know, that's nothing crazy, x minus 2. You know what that is. It's a linear binomial. But now we're going to find the third term of x minus 2 to the 5th. All right, so again, we'll start off with, we have our n now is 5, and our r is still 3. We're still looking for the third term. So I'm going to have 5c3. I'm going to have x to the 5 minus 3. And now my second term is negative 2 to the 3rd. So what's going to happen is we're going to calculate this coefficient, but then this coefficient is going to be influenced by whatever we calculate this to. Okay, so when we don't have another variable, when we're dealing with a constant, a number here, okay, that's going to throw our coefficients off a little bit, but it'll make sense. All right, so just to simplify a little bit, well, let's do the c first. Let's get that out of the way. So 5c3 can be 5 factorial over 2 factorial times 3 factorial. Right, 5 minus 3 is 2. But this one's pretty, oops, that's not what it is. This one's pretty straightforward. It doesn't matter which ones you cancel out, but I'm going to cancel those with those. And I'm going to say that 2 into this 4. So my coefficient is 2 times 5, which is 10. So I apologize, I'm all over the place. So we're going to have 10 times x squared. Now the negative 2 to the third is going to be negative 8. And then we just simplify by multiplying those. So we're going to have negative 80x squared. Okay, and that is my third term. All right, so what it all boils down to is to what we had over here. Okay, so this is kind of our formula, our little cheat sheet to find the nth power. Any questions about that? Okay. Has anybody ever heard of Pascal's triangle?
I don't think so.
Okay. So first I'm going to give you the triangle. Then I'm going to explain to you how we get the triangle. And then I'm going to explain to you how we connect the triangle to our coefficients, our binomial coefficients. All right. So this is a triangle in the sense that, it looks like a triangle, but it's made up of numbers. The top number is just 1. Then the second row is going to have 2 numbers, and they're both 1. My third row is going to have 3 numbers. Those numbers are 1, 2, 1. My ones are looking a little funky there. Let me fix those. I'm just going to put a line. 1, 1, 1, 1, 2, 1. My fourth row has 4 numbers, and those numbers are 1, 3, 3, 1. Fifth row is 5 numbers. 1, 4, 6, 4, 1. And I'll do one more. The sixth row has 6 numbers. 1, 5, 10, 10, 5, 1. And we can keep going on forever with this. Okay, but we can kind of see how it's a triangle, right? Now there's a few general rules. Your outside is always going to be 1. Okay? To get the numbers on the inside here, what we do, how do I want to draw this, is we add up the 2 numbers above it. All right, so if I add 1 plus 2, that gets me 3. 1 plus 2 gets me 3. 4 plus 6 gets me 10. Right? 4 plus 6 gets me 10. 4 plus 1 gets me 5. Right? So let's go one more layer now that we know the trick. So my first number on the outside is always going to be a 1 and a 1. So here, I'm going to have this number here is going to be 1 plus 5, which is 6. This number here is going to be 5 plus 10, which is 15. This number here is going to be 10 plus 10, which is 20. This number here is going to be 10 plus 5, which is, again is 15. And then we're going to have another 6. All right, and again, we're just adding those 2 numbers to get us the number underneath. and that is Pascal's triangle. So it's interesting because these are the exact coefficients to a basic binomial expansion. I want to do this. I want to put it on the side. Yeah, I'll put it on the side. So I'll do it over here, and then we'll zoom out and we'll compare the two. So first, let's just deal with x plus y. We would have x plus y to the 0, and anything to the 0 power is just 1. Then I'd have x plus y to the first, and that would be x and y, and their coefficients are 1 and 1. Let me make this right up here. All right, so we can see that those coefficients match up with that. X plus y squared would get me x squared plus 2xy plus y squared, right? So we have that 1, we have the 2, and then we have a 1, right? 1, 2, 1. And I'll just do one more because this gets a little out of hand. X plus y to the third. 1 x cubed plus, well, what are my numbers here? 3. And then here we start to see that trend with my exponents. Plus 3 xy squared plus 1 y cubed. Actually, let's do one more. X plus y to the fourth. Right, I'm going to have 1, 4, 6, 4, 1. And I'm going to have x to the fourth plus x to the third, y to the first, plus x squared, y squared, plus xy to the third, plus y to the fourth. All right, so if there was some reason that we needed to fully expand a binomial expression, okay, it would be a real neat trick using Pascal's triangle. So let me zoom out a little bit. Oops. Oh, let's zoom out. All right, so we can see the similarities there. And if I wanted to keep going, I could just keep going. And any questions with that?
No, it just gets like a bit complicated.
Yeah, it does. I mean, luckily, I don't want to say this officially, but there's usually, unless you get into some of the higher mathematics in college, this isn't really going to pop up. It's not something that's like, oh, you have to know this. But I think it's something cool that, it is good to know. I think that's really all I got to say about this stuff. Okay, yeah, so what we'll be doing next week is we'll start moving into a newer topic. We're still kind of using these concepts, and we're going to learn something similar to combinations, all right, NCR. and that's called permutations. So we use a P instead of a C. And then, you know, we'll take it from there. And that's going to lead us to probability, which I think is, you know, really important moving on in life. Yeah, and we're wrapping it up. We're almost there, guys. All right. So that's it for us today. You guys have a great weekend, and I'll see everybody on Monday.
Bye, you too.
Bye.
Bye, guys.